Hey, my name is Travis Kassab with TechUXD, and today I have another data science technique that I want to show you guys. It is using a logistic regression to model the probability that a customer churns. And this type of model has two purposes that you can use it for. Explanatory, so which variables are driving the probability that a customer churns, and then also a predictive machine learning purpose, where you can, once the model is trained, you can apply it to a new data set and predict the probability that your current customers will churn or not, right? So, if there's a high likelihood that they'll churn, then you can go in as a company and try to intervene in that process before they actually stop using your service. Also, at the end of the video, I'll talk more about how we can use logistic regression more generally on UX market research and product management survey data. Let's get into it. As I said, the underlying technique for this is called a logistic regression. And I made a video before about something called a multiple linear regression, and they're very similar techniques. But what a logistic regression does is it outputs the probability that an event or outcome will occur. So the output for a logistic regression is from 0 to 1, and it is modeling the probability of a categorical variable, whereas a linear regression gives values from negative infinity to positive infinity. And so it's a numeric outcome variable. So there are two differences here. And then for a logistic regression, the equation is different. It is the outcome is actually going to be the natural log of the odds ratio that an outcome occurs. The data set we're going to use is called a CRM database, and it stands for Customer Relationship Management. And this has variables for each of the customers that have been subscribed to this SaaS product. And each variable represents a characteristic about the customer. And so these are all of our predictor variables. We have 12 predictors in total. And then if you look at the bottom here, we have a churn variable, and this is our outcome variable. It's considered binary categorical. A binary meaning there are two levels, and categorical because it's a qualitative variable, yes or no. Did they churn or did they not churn? And so what we're going to be doing, guys, is using these 12 predictor variables to try to predict the probability that these customers will churn. This is our logistic regression model. You guys, fitting models in R is always so elegant. Look at this simple line of code here. We have the outcome variable churn regressed against all of the predictors, all 12 predictors in our data set. Here is the training data set, and this is a generalized linear model, so we also have to specify the family. And for a binary logistic regression, we're going to use the family binomial. Now with our final reduced model, we can call summary, and we can look at the estimates of the coefficients over here. But before we start interpreting, we need to remember the original equation for a logistic regression, that each coefficient is currently in terms of the natural log of the odds of a customer churning. So at this point, I would only look at whether or not it's negative or positive. If it's negative, it means it decreases the natural log odd of a customer churning. And positive means that it increases the natural log odds of a customer churning. In order to get them into more intuitive terms, the coefficients that is, we would exponentiate each of these coefficients. So if you exponentiate beta, if you exponentiate this side over here, then this exponentiation term turns to actually just the odds of a customer churning. So what was negative above is now going to be below 1. And what was positive above is now going to be greater than 1, and because there are no negatives once you exponentiate. So let's look at tenure, and let's see how we can interpret tenure. So a 1 unit increase in tenure multiplies the odds that a customer churns by 0.96. In other words, for every 1 month increase in a customer's tenure, with all other predictors being held constant, he or she is 4% less likely to churn. So we can see that as tenure increases, a person is less likely to churn. This makes sense. So I just want to show you guys an extreme example here. Now we can say that the customer who has been with the company for 72 months is between 217% and 293% less likely to churn than a customer with 0 months of tenure. This is how influential a numeric predictor variable like tenure can be. We've interpreted the results, and now I want to show you guys the prediction purpose of a logistic regression. So we have a model that was trained on our training data, and now what I want to do is predict the probability that a customer will churn for this new data set. Before this, we actually are going to test the accuracy of the training model on an external data set, our test data set. And we get that with 75% accuracy, our model predicts whether or not a customer is going to churn. So that's pretty good. And so on our current customer CRM, here is the CRM data set here. Each row corresponds to a current customer, and here's our predicted churn right here. So I could imagine an intervention strategy where for every customer where we predict that they're going to churn yes, maybe you send an automated email to them saying, hey, just wanted to check in on you guys. Here's a customer survey. We're trying to understand your pain points and how we can better serve you. So this is the kind of intervention that you can do once you have developed a model that predicts the probability of customer churn. So I just showed you the predictive use case for logistic regression, and now I want to talk quickly about the explanatory use case. And what I mean by explanatory is explaining the relationship between our predictor variables and our outcome variable customer churn. And specifically what I want to know is which predictor variables most significantly drive whether or not a customer churns. The most important thing here, and the difference between our process for fitting the model above and below down here, is that we need to standardize the scales of our predictor variables so that we can then compare the coefficients directly with one another. And the magnitude of the coefficients tell us the degree to which this predictor variable influences the probability that a customer churns. So up here I have standardized all categorical and numeric predictor variable scales. They're all on the same scale. And now we can see that, and then when you do this standardization, you have to understand that you can no longer interpret the coefficients in terms of the original units of the predictor variables. So we lose a lot of interpretability here, but really all that I'm trying to do is just understand the relative importance of each of these predictor variables. So just forget about what the coefficients mean. We're really only care about the sign and magnitude here. And clearly we can see that tenure has the largest absolute magnitude out of any of the other predictors by far. And this makes sense to us, right? So so the longer that somebody is subscribed to your product, the less likely they are in attriting or churning out of your product. And this is negative, right? So this means that as tenure increases, the log odds that the customer churns decreases. We can also see other things too. Subscription 2 years. So if they do have a 2-year subscription, they're less likely. 0.44 is a relatively large magnitude. Kind of also on the same scale, but opposite sign here, around 0.4 for monthly charges, right? So how much they're being charged increases the probability of customer churn. Okay, that concludes my SaaS customer churn example. I have several other examples that I want to give you guys, and this is in the space of UX, market research, and product management survey data, and how you can use logistic regression models to create interesting analyses in here. So the first one I have is a concept test drivers analysis. You show people a concept, you get importance ratings for each feature of that concept, right? So how important is it that feature X is included in this product? And then after all of those importance ratings, you ask the final question, would you buy this product, yes or no? And what a logistic regression model would tell you it would tell you which feature importance ratings most significantly drive intent to purchase. So this is a way that you can prioritize which features you include in an MVP or go-to-market product. The next example that I have is a market research and customer experience example. Everyone knows the Net Promoter Score question, right? So on a scale from 0 to 10, how likely are you to recommend this product or company to a friend or family member? You could try to predict that. You could use that numeric variable as an outcome, or you could condense the numeric variable into its constituent categories for NPS: promoter, passive, and detractor. And you could try to understand which predictor variables are significantly driving detractors, for instance. Last example that I have is a usability test. You're showing respondents a variety of tasks and they're either passing or failing them. There are other metrics that you can use in usability tests for performance, but let's just stick with, let's say there's a really important task and you're trying to understand if somebody passes this task. And you have other characteristics for the usability participants, demographics, technographics, anything. And you want to know what is most significantly related to passing this task. As always, thank you guys for watching this. If you have any specific or general questions, feel free to leave them in the comments or direct message me. I am always happy to get into these conversations about this kind of research and these analyses. And I'm still trying to develop myself as a researcher. I think this is going to be an ongoing process for the rest of my life, and I hope to share it with other people. Thank you, guys.